Section 1.8.1 Arithmetic combination of functions. This video explains sum, difference, product, and quotient of functions. What is arithmetic combinations of functions? If f and g are two functions with overlapping domains, then for all x common to both domains, the sum is defined as f plus g defined over x equals to f of x plus g of x. The difference f minus g defined over x is equal to f of x minus g of x. Product f times g defined over x is equal to f of x times g of x. And the quotient f over g defined over x is f of x over g of x, provided the g of x is not equal to 0. Domain of combinations of two functions. Given functions f and g. Number 1. The domain of f plus g defined over x, f minus g defined over x, or f times g defined over x, is the set of all real numbers that are common to the domains of f and g. Number 2. Domain of f of x over g of x is the set of all real numbers that are common to the domains of f and g for which g of x is not equal to 0. So here is example 1. We are given f of x equals to 2x minus 5 and g of x equals to 2 minus x. So we determine f plus g defined over x, and then we write the domain of f plus. So by definition, f plus g defined over x is simply equals to f of x plus g of x. Now we substitute f of x equal to 2x minus 5 and the g of x equal to 2 minus x. So we get 2x minus 5 plus 2 minus x. Now we just open the parentheses. You have a 2x minus 5 plus 2 minus x. So we can combine the like term like 2x minus x is x, minus 5 plus 2 is negative 3. The next thing we're going to find the domain of this f plus g defined over x. But we need to know what is the domain of the original function. Well, original function is a linear function, is a polynomial. And we know the domain of polynomial function is all real numbers. But in interval form, you can write negative infinity to infinity. Similarly, the domain of function g of x, again this is a polynomial. The domain of g is also negative infinity to infinity. Now we take the intersection of these two domains, and that will be the domain of the f plus g. The intersection of these is also minus infinity to infinity. So therefore the domain of f plus g is minus infinity to infinity. Example 2. So we are given f of x equals to 2x minus 5 and g of x equal to square root of x minus 2. So we'll determine f minus g defined over x, and then we write the domain of f minus g. So we start with f minus g defined over x, which is f of x minus g of x. Now we substitute f of x equal to 2x minus 5 and g of x equal to square root of x minus 2. So we have a 2x minus 5 minus square root of x minus 2. So then nothing to combine. So this is our answer to f minus g defined over x. Now to find the domain of f minus g defined over x, we need to know what is the domain of f of x and what is the domain of g of x. Well, f of x is a polynomial function, and so the domain of f equal to 2x minus g is simply minus infinity to infinity. But to find the domain of g equal to square root of x minus 2, we simply take the x minus 2 set greater than or equal to 0 and then solve for x. X greater than or equal to 2, and now we write this in interval form, it should be 2 to infinity. Because of e greater than or equal, we're using square brackets. Now we take, to find the domain of f minus g, we'll take the intersection of domain of f, which is minus infinity to infinity, and the domain of g, which is 2 to infinity. Now, if the common of these two domains is square root of 2 comma infinity. So that's the domain of the f minus g function. So here is example 4. We're going to find f over g defined over x. And I write the domain of f over g defined over x. Where f of x is 2x minus 5 and the g of x is 2 minus x. So we start with f over g defined over x, and by definition it's simply f of x divided by g of x. So we substitute f of x equal to 2x minus 5 and g of x equal to 2 minus x. Nothing to simplify, so the answer to f over g defined over x is 2x minus 5 over 2 minus x. Now, to find the domain, first we find the domain of f. The domain of f, because a polynomial function, all real numbers, or you can say minus infinity to infinity. And the domain of g is also minus infinity to infinity because this is also a polynomial function. Now, to find the domain of f over g is simply take the intersection of minus infinity to infinity, and which is the same as minus infinity to infinity. Now, if you notice, if I substitute 2 in the denominator, it becomes 0, and we know division by 0 is undefined. So therefore, there is a restriction to this function, and we have to remove that restriction from this domain. So what we do, we will exclude x equal to 2 from this, from minus infinity to infinity. So, well, then therefore the domain of this function would be negative infinity to 2 parenthesis union 2 to infinity. Example 5. We are given now the graphs. This is the graph of f of x and this is the graph of g of x. And we want to find f plus g defined over 2. So we start with f plus g defined over 2. So by definition, we simply first find f of 2 and then find g of 2 and then add. So well, let's see. So from the function f of x, to find f of 2, we'll create the 2. Let's say 2 is here and the graph also touches here. So there f of 2 is simply 0. Now g of 2, so let's say 2 is here and you go up and this gives you what? 4. So g of 2 is 4. So simplify, so the answer is 4. Example 6. So we are again given the graph of f of x and g of x. So this time we have to find f over g defined over 3. So let's start. F over g defined over 3, by definition, it should be f of 3 over g of 3. So from the graph we find f3. So let's see. This is 3, and if you go up and you go, this is equal to 3. So f 3 is 3. Similarly, g of 3. So it looks like a 1, 2, 3, and you go up and you go here, and it's also 3. So 3 over 3 is simply 1. So the answer to this question is 1. Example 7. Again, we are given the graphs of functions f of x and g of x, and we have to find f minus g defined over 3. So f minus g defined over 3 is simply f of 3 minus g of 3. So from the graph, so here is a 3. So this gives you 3 also. So f of 3 is 3. G of 3. So here is 3, and this gives you 3 also. So 3 minus 3 is 0. Example 8. We are given the graph of f of x, graph of g of x, and we have to find f times g defined over 4. So we start with this. F times g defined over 4 is simply f of 4 times g of 4. So to find f of 4, we go here, and this is 4 looks like, and we go up, and this looks like a 6. So f of 4 is 6. Similarly, to find g of 4, we looks like 1, 2, 3, 4. This 4, you go here and this gives you 2. So g of 4 is 2. So you have 6 times 2, which would be 12.